What's up, folks? This is the Savage Scientist Ed, and today we're going to talk about big O notation. And big O notation is important for those FAANG interviews or data structure courses that looks at the analysis of algorithms. So big O notation is normally written as O and then some function. So that function is the complexity. So this is the complexity. And we can see the complexity as the most, or the function that gives the highest value on its output. So a factorial will be here, n factorial. We would have O of n cubed. And our complexity of O of n squared would be here. O of n complexity would be here. And we would have one of our best O of log n. Or sometime, and the best complexity, which most of the time impossible to produce, will be O of 1. That is our constant time complexity. So they will ask you a question on leak code or interviews, or as you produce these algorithms, they'll ask you stuff like, I want you to produce an algorithm that has O of n complexity. So we have the insert function. So it'll say produce an insert function with best time, and let me put this on the board right quick. So it'll say best time, O of 1, worst time, O of n. So that means we're going to be using this one and O of n. O of n, O of 1. Alright, so let's get all this out the way. And now we're about to look at the algorithm itself. So O of 1. So that best time will be inserting right here. That'll be the first element into this array. So the worst case scenario will be if we have to insert at the last element. That would be n. So, the end of it, meaning END. So, the most important thing to understand is, what is n? N means how many elements are in the array. In this example, P has 1, 2, 3, 4, 5 elements. So, if I want to insert in the front, I'm going to call it 1 time and put our 1 here. So, if I decide to do, if I insert in the last one, I'm going to put it here. So that means I'm going to have to start here, go to this element, go to this element, go to this element, and then go to that element. And that means that by looking at this, that we have O of n1, when we could tell that this is using a linked list. So there's an example where you could have a best case and worst case both O of 1 on insert. And that would be if you used an array. Because in an array, we start here and our index values are dependent upon knowing the location. So we would use number 1 and add the offset to it. So to get to this element, or if we had a 5th element, we would just say 1. So we'll get the element here and then add 4 to it. And in C++, we would have something like this. We would have a head pointer, and then we're going to say head plus 5. That means we are going to start here. This is the head. Plus 1, plus 2, 3, 4, 5. And that means we here. That means we don't have to visit the first one, the second, third, and fourth. We know the first one, and then we're going to add the offset to the 5th one. So we jumping from the first element to the last element. And that is why an array is more efficient at this insert. And that's why your best and worst case scenarios are both linear time. So one thing you have to think about is, hey, Savage, you started off with this at this first one, and you still have to know the first one, and then this whole jumping thing, that means that you had to take a second step to get here. That's cool. So let's say our N was 5,000. We still only had to do 2 steps to get to element 5,000 and put our insert right here. But in this one, we would have to go through 5,000 elements to get to the 5,000 spot to insert our element. So that's the difference here. So O of 1 versus O of 5,000. That's why using a linked list will not be efficient when compared to an array in stuff like this, in basic inserts. So I hope that cleared up a little bit for you on why you should use linked lists versus arrays. And we're going to talk more about this on my channel as we dive deeper into big O notation. Till I make my next video, peace out.